Okay, let's dive right into this. Welcome to today's Explainer, where we're going to unpack the surprisingly active and honestly kind of mind-bending reality of something you probably look at every single day. I'm talking about the everyday houseplants sitting quietly in your room. We tend to view our potted pothos or towering monstera as, just passive background decorations, totally frozen in place. But what if the stillness of the plants in your living room is actually just a grand illusion?
It's a wild thought, right? What if your houseplants are actually hunting? Now, the truth is, plants only seem frozen to us because of the limits of human time perception. Our eyes just aren't built to process their speed. But if we hit the fast-forward button on a camera, a terrifying or, fascinating new reality emerges. Plants don't just sit there. They crawl, they reach, they hunt.
And this brilliantly illustrates the massive gap in how we see the world. On one side, we have our human perception, where plants are just pretty, passive background decorations. But the biological reality, they are active, crawling, slow-motion predators, operating in this entirely different, slower dimension of time. They're actively stalking their environment. So today, we're going to break down exactly how these invisible hunters operate.
So let's start with part 1, the circular search. When a climbing plant, think a pothos or maybe a runner bean, sends a new vine out into a dark room, it doesn't just grow straight out and hope for the best. It initiates this brilliant botanical maneuver called circumnutation. Basically, it's a continuous, rhythmic, sweeping pattern. The plant is essentially casting a giant biological net to find climbing support, and it does this through an internal clock that dictates uneven cell growth. Cells on one side elongate while the other side slows down, and that forces the tip of the plant to swing blindly through the air in sweeping loops.
Now, you might be thinking this sounds like some newly discovered biological magic, but is highly verified science that's been documented for well over a century. Charles Darwin himself heavily documented this whole process way back in 1880, proving that, as he put it, continuous helical movement is an inherent property of plant growth. So this sweeping motion isn't a fluke. It's absolutely fundamental to their survival.
All right, moving right along to part 2, seeing the light.
So, while a new vine might sweep blindly for physical support, a plant's hunt for energy is incredibly precise. Plants obviously don't have eyes, but they do actively see their environment. They use an advanced network of light-sensitive cellular proteins called phototropins. These brilliant little receptors are specifically tuned to detect blue light frequencies, which lets the plant accurately track light sources across a room and perfectly reorient its flat surfaces to maximize its solar collection panels. But how does sensing that light actually translate into movement? Let's look at how this builds. It triggers a highly precise cellular chain reaction. First, blue light hits those phototropin receptors on the leaf. This triggers a rapid migration of a growth hormone called Auxin, which basically immediately flees to the shaded side of the plant. Because of that hormone surge, well, actually, scratch that, it's more like a hormone retreat to the shadows. The cells on the dark side stretch out. With one side suddenly physically longer than the other, the entire stem bends cleanly toward the light source. It's a fully automated steering mechanism happening right there on your windowsill.
Which brings us perfectly to part 3, the tactile ambush. We've seen how they search, and we've seen how they steer. But what happens the exact moment that blindly sweeping vine makes physical contact with, say, your bookshelf or a moss pole? The hunting strategy instantly shifts to a full-on ambush, driven by something called Thigmotropism. Now, what's really interesting about this is that it's a plant's acute sense of touch. Certain climbing species are so sensitive that a touch literally lighter than a human hair triggers an immediate structural shift. Faster than you can remember to water them, mechanical friction sets off rapid, asymmetrical cell growth, transforming a soft, straight tendril into a grappling weapon. So the crucial point here is how this incredible sense of touch creates what we call the lasso effect. Within minutes of touching an object, the cells directly in contact with it shrink, while the outer cells rapidly expand. Within hours, the tendril forms an iron-clad spiral grip. But it doesn't stop there. Once it's locked in, the plant acts like a mechanical spring. It contracts the rest of the vine into a tight coil, hydraulically winching its entire weight upward to conquer the canopy. When you put all these mechanisms together, the circumnutation, the phototropins, the thigmotropism, you realize something really profound. The next time you walk into a room and notice a vine has mysteriously shifted its position, remember this. You are living with a silent, hyper-calculating hunter, an organism that continuously moves, tracks, and completely reshapes its own body every single day just to survive.
But here's the catch.
Capturing light and locking onto supports means absolutely nothing if the plant cannot breathe. To survive, these hunters must do exactly that. So I'm going to leave you with this question to chew on. How exactly do they open millions of microscopic snapping jaws hidden directly underneath their leaves to inhale toxic air and exhale life? That hidden world of atmospheric gatekeepers is a fascinating story for another explainer. Thank you so much for exploring the hidden world of plant movement with me today. Keep observing, keep questioning, and I'll catch you in the next one.